Welcome to this explainer. Today we're diving straight into an introduction to prompt engineering. But we are going to do things a little differently. We're moving completely away from crossing our fingers, closing our eyes, and hoping for some kind of magic words to work. Instead, we're going to master the actual mechanics of how these AI engines function. It's time to stop treating AI like a mysterious black box and start treating it like the precision tool it actually is.
To really understand where a lot of us go wrong with AI, we have to look at a pretty fascinating piece of history. Picture this. During World War II, Pacific Islanders watched airplanes drop incredible supplies right out of the sky. After the war ended, they obviously wanted those supplies to return, right? So they built fake runways, wooden control towers, even carved out little coconut headphones. Researchers actually point out that so many of us do this exact same cargo cult behavior with AI today. We copy viral prompts off the internet, paste them in without understanding the underlying mechanics, and just kind of hope the right results will magically drop from the sky.
So the crucial question you've got to ask yourself right now is this. Are you actually engineering your AI outputs, or are you just blindly pasting rituals and hoping for the best? Because copying the shape of the runway isn't going to make the planes land.
Here's our quick roadmap for today. First, we'll move beyond the magic words. Second, we'll unpack the probability engine. Third, we'll look at memory and mechanical limits. Fourth, we'll open up the prompting toolkit. And finally, we'll master chain of thought.
All right, let's jump right into section 1, Beyond the Magic Words, and how we evolve past the viral prompt.
Rather than treating the AI like some all-knowing oracle, we really need to start treating prompting as an iterative debugging process. A lot of people think that just throwing more words at the AI equals a better output, but it's actually all about precision. Prompt engineering is simply using structured language to narrow down the possibilities. And just like writing really good code, high-quality results are rarely a one-and-done deal. It usually takes a good 3 to 5 cycles of tweaking and refinement to finally hit that diamond at the bottom.
Moving on to Section 2, the probability engine. Let's lift the hood on these large language models and see what's really going on.
Okay, this is a massive paradigm shift. AI models don't actually know facts the way a traditional SQL database does. They act as autoregressive probability engines. Basically, they process pieces of words, which we call tokens, and calculate the raw mathematical probability of what token should naturally come next based on billions of training patterns. They are pattern simulators. You aren't actually asking it a question. You are providing a starting sequence that the model is mathematically compelled to complete.
Think of this process as probability narrowing. A vague prompt like, hey, build a login page, gives the AI a massive, frankly overwhelming range of possibilities. And what does it do? It spits out a generic, often completely useless output. But look at the difference when we use a constrained prompt. By specifying the exact tech stack, say Next.js, TypeScript, Tailwind, and adding constraints like accessibility, you are grabbing the steering wheel. You are filtering out that vast probability space to force a highly precise, expert-level output.
Section 3, Memory and Mechanical Limits. Let's talk about context windows and the dials of creativity.
You always have to work within the model's working memory, which we call the context window. Literally everything you send, your prompt, any external documents, the conversation history, and the AI's response itself has to fit inside this box. This is a hard physical constraint tied directly to GPU memory bandwidth, and it scales dramatically depending on the model. It ranges from 128,000 tokens in models like Llama 3.1 all the way up to a totally staggering 2 million tokens in Gemini 1.5 Pro. But a quick warning here. Just because a window is huge doesn't mean the model won't lose track of important information buried right in the middle of it.
Now, another mechanical dial you have complete control over is the temperature setting. Temperature essentially scales those raw prediction scores before the AI actually selects the next token, and this is typically on a range from 0.0 to 1.5. This single, simple setting fundamentally gives you control over the randomness in the perceived creativity of your outputs.
The absolute crucial point here is matching your temperature to your specific task. If you're doing something like extracting structured data, classifying sentiment, or generating strict JSON, you want a low temperature, something between 0.0 and 0.3. This forces the model to be highly consistent and deterministic. Setting the temperature too high for a structured coding task will introduce randomness that will literally break your application. On the flip side, keeping it at 0.0 for creative writing or brainstorming will just give you robotic, super repetitive text right when you actually wanted diversity and flair.
Section 4, the prompting toolkit. Let's get into some actual tactics for steering this engine.
It turns out you really need to act as an architect for the AI by using delimiters. These are basically boundary markers that cleanly separate the different sections of your prompt. You can use quotes for specific text, triple backticks to signal code blocks, or XML tags to provide clear semantic structure. By creating these predictable, hard boundaries, you physically stop the model from jumbling all your context and instructions together into a messy soup.
Building a truly reliable prompt requires a highly systematic process. First, you assign an instruction and a role or persona. This immediately sets the vocabulary and the depth of the response. Second, you establish context and strict constraints to keep the model from drifting off topic. Third, you implement chain-of-thought reasoning for complex logic. And finally, you fully expect to iteratively refine the output. Remember, it's a process, it's not just a single magic command.
Now, researchers have uncovered a fascinating psychological quirk these mathematical models have: recency bias. When testing the order of examples in a prompt, accuracy can literally swing from a coin flip all the way to state-of-the-art, simply based on the sequence you use. LLMs pay the absolute most attention to whatever you put last. So the huge takeaway here: always place your most important, clearest example at the very bottom of your prompt, right before the AI starts generating its answer.
And that brings us to Section 5, Mastering Chain of Thought, where we are going to shatter a few final myths.
We've all seen that viral advice online telling you to just add the phrase, "think step by step," to the end of your prompt, right? Well, research shows this is actually highly situational. It flat out fails on smaller models, anything under 100 billion parameters, causing them to generate fluent but completely illogical steps. Even worse, applying it to simple pattern recognition or visual tasks just overcomplicates things, degrading the model's accuracy by up to 36%. It's kind of like asking someone to logically, step by step, explain exactly why they find a painting beautiful. The more they overanalyze it, the worse their intuitive judgment gets.
This brings us to a massive DeepMind study that completely destroyed human guesswork. They pitted 20 hours of human prompt engineering against automatic AI-generated prompts. The results were completely staggering. The AI-optimized model-specific prompt achieved an 80% accuracy rate compared to a mere 34% from the human-crafted ones. The big lesson here: there is absolutely no universal magic phrase. The optimal prompt is always task-specific, and it's always model-specific.
Well, we've covered a lot of ground today. You now know that AI is an autoregressive probability engine, it's constrained by context windows, and it's steered by temperature, delimiters, and systematic constraints. It is absolutely not a magic 8-ball. The folks who will get the most out of AI aren't out there chasing viral prompt hacks. They are experimenting, testing, and measuring their results. So the only real question left to ask is, when you sit down at your keyboard tomorrow, will you just be typing, or will you be engineering?